Hello! So, this is the video that goes along with the notes for lesson 1. I'm going to try it this way, not to use my document camera. You wrote down the notes, and so hopefully this will work. So before taking notes, make sure you watch the Nearpod video because we're going to talk a little about that. But this is lesson 1. We're going to do number systems or number types and evaluating expressions or evaluate. Okay. So first, in the video that you watched, they had something like this, but they had counting numbers here. I don't know why my stylus does that. Counting numbers here, okay? So inside the middle are counting numbers, how you learn to count. 1, 2, 3, 4, 5. You didn't learn about 0 until you learned about natural numbers. So these are all in your notes. I put these examples. Right here, these fancy things I don't really use. The one I do use is real numbers, and I'll talk about that when I get to that. Next are integers, so positive, negative, these are whole numbers, so 1, 15, negative 1, negative 2, negative 3. Rational, ratio is in that word. Ratio is a fraction, or you could have a fraction like this. Or you could have a decimal, which is 2 1/4. But these end or repeat, like it ends right there, or you could have 1.77 and that repeats, that's the line over the 7. Irrational are next. If someone's being irrational, they're not really making sense. These never end or repeat. When we type the symbol, it doesn't make the square root continue right there, but that root. But there's positive and negative. Pi is the most famous irrational. E is about 2.7, like pi is about 3.4, but that 3.14, but that's rounding. To write something like this with the symbol, or to write it like this is exact because there's no operations being done to round. Transcendental we don't really use, but all of these are irrational. And this whole egg, the reason they had it here, but I don't like it inside, but this whole oval, the entire oval, are real numbers. We use the real number system. When you're in Algebra 2, you'll learn about this other number system called complex numbers. But right now, in Algebra 1, we use the real number system. And a lot of times I say that 2 lines and the R means real. The entire number line, every decimal, every positive, negative number goes off to positive infinity to the right, negative infinity to the left, 0 in the middle. Those are real numbers. So I want you to try this warm-up, pause, and then I will show the answers. Please try them though. Make sure you understand what each one means or how to do them. So here, remember when you add or subtract, you have to find a common denominator. 2 times 5 is 10, so this becomes 5/10 plus 2/10, and that's how we get 7/10. But when we multiply, you can multiply straight across. 1 times 24 and 6, there's a 1 under here. 4, there's a 1 under there, so that equals 6. You could also think the 4 is in the bottom, so it's division. So 24 divided by 4 is 6. 6 times 1 is 6. Decimals, you could divide. You could think of this as 182 divided by 2. That's 91. But what's different is I have this decimal right here, so you need a decimal with 1 place there. You could also use a calculator, always, okay? Not the math app, but the calculator. So today we're going to translate words in algebra. Math is the language of the universe, and so you need to know that language and you need to know some vocabulary. And that's what I put in the notes with the dashes. You could make your notes as fancy as you want with highlight, underline, different colored pens if you'd like. Order of operations we're going to talk about very quickly. We're going to spend more time on this later, but these are foundations to what we're going to use all year, and we're going to show how to evaluate expressions. So that's the evaluate part. So vocabulary, let's go over it, and it is in your notes. So the first one I started with is a variable. A vary can change, vary. It's a letter. We use X. It could be a heart if you wanted. It could be a squiggle. Squiggles kind of look like Greek letters. A constant means it doesn't change, so I have like 5, never changes. If I say 48, you know exactly how many that means. A numerical expression, so numbers and operations. 2 plus 7. Okay. 3 times 2 divided by 8. Just numbers. Algebraic expression, 2x, z, 5xy. Those are algebraic. You could also have pluses or minuses. The next one I did, I believe, was evaluate. So this one says to find its value. When we evaluate an expression, you plug in numbers, constants in for the variables, and you get a total out. They are not equations. These are not equations. These are expressions. There's no equal sign. You're not solving. You're just finding a total, what represents that expression. And then order of operations is PEMDAS, parentheses, exponents. I use that for exponents. It's called a caret because it's usually on calculators, multiplication, division, addition, subtraction. And each of these are opposite of each other. Multiplication, division, and addition and subtraction. Those are opposites, but not crisscross. So we use the PEMDAS to evaluate expressions and solve problems. So when we are solving equations, you actually do PEMDAS backwards. Okay, so these big words, sum means to add. We don't have other symbols for add. Difference means subtract. We don't have other symbols for subtraction. Times. We don't use an X in Algebra 1 because the X is a variable. I use a star. That's to multiply. We could also use parentheses. We could also use a dot. We could also put the variable right next to the number. I'm just going to use that example. Quotient is to divide. We could use a slash. We could use a fraction like this. And if you notice, the division symbol is like a fraction. There's something, the numerator, denominator, and the fraction line, because dividing is fraction. So know those words that we could do: sum, difference, product, and quotient. Adding, combining, more, subtracting, less, difference, multiply, you put into equal groups, and divide, you separate out into equal groups. Sorry, I don't mean to cross things out. I'm trying to underline. If you want to add more notes, you could go on to the right page, which would be page 4, the right-hand side of your notebook, or if you've already written on the left, that's fine. Okay, Roberto is 4 years older, so older means adding. Adding or multiplication, I could write y plus 4 or 4 plus y. They mean the same thing. But division and subtraction, you can't just flip-flop terms. So if I were taking notes here, you only want important information if you want to write these down. I didn't write them in notes. $5 for each car. How much does he earn in dollars? 5 times car is how much he earns. So if I have dollars divided by 5, if he earns $30 and he gets $5 a car, he's washed 6 cars. 65 miles for 1 hour. So how far does he drive in T hours? That's 65 times T. If it was 3 hours, it's 65 times 3, which is 195, I think, 180 plus 15. Miriam is 5 centimeters taller, so this is another addition. It's like the older. $32 a day, how many days? So you just multiply. So if she works 2 days, it'd be $64. I know I'm going fast, but you could pause at any time. I don't want my video to give me an error. All right, evaluate. These are on the left-hand side of the notes. For evaluating, you put in A equals 4. So every time you see an A, you're going to put a 4. B equals 7. Every time you see a B, you put a 7. You do keep the symbol, the operation as it is, okay? If these were negative, you still keep the operation there, but C may be a negative number. But I don't think we have negatives yet. So B is 7, C is 2, 7 minus 2 is 5. This is multiplication, they're right next to each other. 4 times 2, 4 times 2 is 8, okay? And then these, M is 3, N is 2, P is 9. So this is multiplication, this is subtraction, this is division. I want you to try it, pause, and come back to the answers. So now multiplication, 3 times 2 is 6, subtraction, 9 minus 2 is 7. Division is 9 divided by 3. So you could also think of this as P divided by M, or 9 divided by 3. Because a division symbol and a fraction are the same thing. So I wanted to show you this because sometimes there's an 85, there's 20 ounce, a sleeping bag, that's one sleeping bag. 20 ounce is not needed, how big the plastic bottles are. Take a second and read it. I know I'm going along quickly, I don't want my video to run out, but pause it and read stuff when I show new stuff on the screen. 85 for one sleeping bag, so how many for S sleeping bags? That takes 85 times how many sleeping bags there are. So this is your assignment, the even numbers, period 1, 2, and 4, 3, 4, you do the even numbers, period 7, you're going to do the odd numbers. You're going to evaluate these expressions. Remember, you're not solving. There's no equal sign on the expression. There is an equal to tell you how much X and Y are. Remember to follow PEMDAS. Like 83, you're going to do parentheses first, and then you're going to square after it. You don't square first because that's an exponent. Here, you're going to square because it's the exponent, and then you're going to add last. Here, you're going to do what's inside parentheses and then exponent, okay, because parentheses is the first P in PEMDAS. And then the second half, you're going to write these out as an expression. So period 1, 2, 3, 4, you do evens, period 7, you do odds. Now, let's hope my video works. Let me know if you have questions in class.